Hello guys, welcome back to the channel. So today in this video we are going to solve the first problem of weekly contest 264, and the problem statement is identify the number of valid words in a sentence. Okay, and it is tagged as easy problem. So I will just quickly read the problem statement and then we will move to solution and see how to approach it. So a sentence consists of lowercase letters, digits, hyphens, punctuation marks, and spaces only. Each sentence can be broken down into one or more tokens separated by one or more spaces. A token is a valid word if it only contains lowercase letters, hyphens, punctuation, and no digits. Okay, there is at most one hyphen. If present, it should be surrounded by lowercase letter, that is, it should come between the alphabets, and there is at most one punctuation mark. If present, it should be at the end of the token, means it should come at the last of the word if it is present. Okay, and the quantity of both of these should be 1 1 each. Okay, now given a string sentence, return the number of valid words in the sentence. Okay, means we have to count the number of valid tokens and just return the number. So let's see an example. The given sentence is cat and dog. Okay, since it is made up of only like alphabet, so it is a valid word. Now, if we see this, the first token, you can see that the punctuation mark is coming at the very first, but here the third rule says that it should be present at the end. Okay, this will be invalid. Then 1 hyphen s. Okay, here a digit is coming, so it should then again become invalid. Then B8D exclamation mark, then it is again digit is coming, so it is invalid, so we get 0 here. Okay, nice. So after seeing the example, the thought is coming that we have to check all the tokens one by one, and we have to perform these checks. And if all the three checks are valid for a given token, then we should include it in our count, and otherwise we will move to the next token. So I think in this way we should approach the problem and it will get solved. So let's try to code, and we will see like what will the condition and how we will going to approach it. So we have given a sentence, and to take out every word one by one, we can use the library string stream. But before that, I think we should first create a variable count that will store the valid tokens in the our sentence. So after that we will just use the string stream library, string stream, and we will just use the variable s, and like that. Now we will create a temporary string word, then just we will iterate in the while loop. Since we have to perform all these three checks for each and every token, I think it will be more suitable to make a function. So let's just define the function, that is if valid token, then we will just send the word as the argument, and if it is valid, then we will just do plus plus count. Okay, and then we just return it, nothing else. But before that, we have to make this function that will perform all the three conditions. So it should be a bool type, and it will be getting a string as an argument. So string ampersand s, name it as s. Then after that, I think we should make a variable that will store the number of hyphen that we have encountered, and similarly for the punctuation mark. So in this way we should proceed. So let's create h count is equal to 0 and p count is equal to 0. Next, just iterate over the uh, given string. After that, Now, as the first condition is saying that it should not contain any digit, so we will just perform the check. If si is greater than equal to 0 and si is less than equal to 9, as it will be the digit from is 0 to 9 only, so we will just return false as it cannot contain any digit. After that, what is the second condition saying? And there is at most one hyphen, okay, present in surrounded by lowercase. It means that the hyphen cannot come at the very beginning and at the very end. So make an if condition, else if our character uncounted is a hyphen, then we have to perform some check. And what will be the checks? It should not come at the very beginning. For that, if I minus 1 is less than 0, that means it is coming at the very beginning, that is I is equal to 0. Or it should be also surrounded by the alphabet. So if is alpha, we can use the function, the character that we are seeing, that is hyphen, and before that if it is not a alphabet, then we should return false. After that, if the character that we are seeing, that is hyphen, and after that it is not an alphabet, then again we have to return false. So before that we should first check the index, that is if I plus 1 is should not be greater than equal to n, that means it is out of the index. So in that case also we have to return false. After that we have to perform this same check, like if there is a character present and if it is not an alphabet, then again we have to return false. Okay, I think second condition is now over. Okay, there is at most one hyphen, means the number of hyphens allowed is one only, then we have to again count the hyphens. So here we can do that. If it is not going in this if condition, that means we have to increase the h count. Okay, okay, now if here we can perform the check. If h count is greater than equal to 1, then we should return false, as the hyphen count is allowed is only 1. So I think the second condition can be checked in this way. Now what else? We have to check the third condition, and there is at most one punctuation marks and it should be present at the end. Only one is allowed punctuation mark and it should be at the end. I think there is no need to count the punctuation, since it is coming in between from 0 to n minus 2, then it will become invalid at is it is not coming at the very end. So I think we can perform a check like that. If si, it's a punctuation mark which are allowed, si equal to comma or si equal to exclamation marks, then we know that we have encountered a punctuation mark. And in this, if I is not equal to s dot length minus 1, then we will return simply false. Okay. Other than that, that means that we are getting an alphabet, and we know that the alphabet is allowed in the valid word. So I think after these checks, it should be returned true. Okay, now after that, when we have completed the for loop, we should return true. If, otherwise, if we encounter any invalid condition, then from that there only we have returned false. So if it is ending the for loop, that means it is a valid word. So we should return true from here. So I think it should be good to go to check. Let's run the code. We got a compiler error. Okay, we have not defined n and I have used it here. Should just length only. And again, we can just see cat and dog. We have got three. Okay, it's three only. Now just run for every example case. Just run the code. We see 3056 is our answer and expected answer is also same. So I think we are good to go and try to just so yeah, it got accepted. So I think in this way we can solve this problem. The time complexity must be O of n into m, where n is the length of the sentence, that is the tokens, and m is the length of the length of the each token. So we have successfully done the problem. So let's meet with the new problem in the next video. Till then, stay tuned, stay happy, and happy coding.